How's it going, everyone? It's Chow here, and today we are going to talk a little bit about phylogenetic trees, more of just an introduction to it. We'll talk about how to read them in another video, but this is just an intro discussing the different types of phylogenetic trees that you might see in terms of grouping, and let's just get started before we take up too much time. So when we're looking at phylogenetic systematics, there are sort of three main groups that are often found, at least in terms of an introductory bio classroom. And the first type is monophyletic, also known as a clade, which is shown over here, paraphyletic, which is shown over here, and then last but not least, a polyphyletic grouping, which is shown over here. So this is the starting point, and it's good to know the which particular group is which. So that's just the main different types of groupings. You should get to know these because that will help you a lot on your exam as well as in future courses. Okay, so let's take a look at monophyletic groups first, also known as clades. So you can kind of use these terms interchangeably, monophyletic versus clade. And so a clade consists of one common ancestor and all of its descendants. So we're looking at a complete family. Each clade can be nested inside other larger clades, and clades are the only natural group that occurs within the natural world. So let's take a look at this particular thing over here, which is in this purple-ish triangle. We're designating a monophyletic group. So a monophyletic group is this one over here that's circled in purple, I guess triangled in purple. Is that even a word? So a clade consists of one common ancestor and all of its descendants. So B is the common ancestor, and we can see all of its descendants over here. We have C and F, which eventually gave descendants to DE, and then F to GH. And so common ancestor and all of its descendants, that's a clade, also known as a monophyletic group or a monophyly. Each clade can be nested inside other clades. So this group over here, consisting of C, E, and D, can be another clade or another monophyletic group. So fulfilling the second thing here, each clade can be nested inside larger clades. So this CDE can be another clade, remember, common ancestor, as well as all of its descendants. This is a clade, and it's being nested inside another clade. And obviously this is the only natural group because that's what occurs naturally in the world. So just try to kind of understand this particular grouping over here and how these can be clades over here. So C, D, E is a clade, G, F, G, and H, this is a clade, and this entire thing is a clade here also. In addition, I can choose something else over here. So I, J, and K over here can also be considered a clade if you decide to circle that. And also, this entire thing with A, B, C, F, I, J, K, G, H, D, E, if I circle this entire thing and use A as our common ancestor, this also can be a monophyletic group, aka a clade. So depending on what you circle and what you choose to kind of differentiate and separate from everything else, can also depend on whether something is a clade or not. And obviously a clade can be just anything with a common ancestor and all of its descendants. It can be a big clade, it can be a small clade, doesn't matter. Because this is the first group that you're most likely going to encounter, and that's the monophyletic group or the monophyly, aka the clade. So an example of this is actually Archosaura, which is shown over here. So you can see the common ancestor over here, and then all of its descendants include, so Archosaura includes crocodiles, some of your dinosaurs, as well as your birds. And you can see that this entire group here, all of its descendants and the common ancestor, and that's a clade, aka a monophyly, aka a monophyletic group. So that hopefully makes sense. The second group is the paraphyletic group. The paraphyletic group consists of an ancestor, so we're still choosing one single common ancestor and one line of its descendants, or maybe even more than one line of its descendants. Or I guess I should say, let's make a change here. So consists of an ancestor and some of its descendants. That might be a better way to put it. So you can actually include other things over here if you want, but the important part is this over here. it leaves out some of its descendants in the picture. So when it comes to a paraphyletic group, I'm choosing a common ancestor and some of its descendants, but I'm excluding other descendants. But that entire group still has that common ancestor. So they're not natural groups because they're not really clades, and that's kind of the secondary thing. But paraphyletic groups do occur in some kinds of taxonomy because sometimes phylogenetic trees as well as morphological trees don't necessarily correlate. But what's really important about paraphyletic groups is that you're accounting for the common ancestor, but you're excluding some of those descendants. So we have the common ancestor A here, but we are excluding all these descendants over here, as well as this descendant over here, J. That's a paraphyletic group, and you should definitely get to know that. So an example of this is we're using Archosauria again, but we're excluding birds. So maybe choosing something like Stegosaurus, Tyrannosaurus, Velociraptor. We're choosing dinosaurs, but we're excluding birds. It's interesting because if you look at it taxonomically, if you choose dinosaurs but exclude birds, that's actually a paraphyletic group. So the way that we consider dinosaurs, if we don't consider the birds and the crocodiles in there sometimes, that actually can be a paraphyletic group. So as you can see, we have that common ancestor over here, and we have some of its descendants, but we leave out some of the descendants, and that's a paraphyletic group. Last but not least, we have a polyphyletic group, which is basically consisting of descendants of a common ancestor, but we actually exclude the common ancestor. So you can see over here, we include the descendants, but we exclude the common ancestor. So that's kind of the key thing to help separate polyphyletic groups. A polyphyletic group, one of the easiest ways to separate it is if you can see the descendants being chosen, but the common ancestor being excluded. So we're including the descendants, but we're excluding the common ancestor. No common ancestor, that should start shouting polyphyletic group to you. And again, these are not really natural groups in the wild because they're not really clades. So let's use an example here, winged tetrapods. We have the descendants, the bat over here, and the hawk, which is a bird over here, but we're not including the common ancestor, which is over here, and so that is a polyphyletic group. So we can use phylogenies in very interesting ways because we can look at certain characteristics that have arisen over time and see where it evolved. So one particular interesting characteristic is parental care. So we can see that parental care occurs in crocodiles, we can see it in birds, and we don't really see it in turtles. So we can use our knowledge that crocodiles have parental care, birds have parental care, and based on our knowledge of how a phylogenetic tree is structured, let's just say this is correct, we can assume that parental care likely evolved here because that's the most parsimonious explanation, the most simple explanation. And so it probably evolved over here. Whereas if we think that parental care evolved over here and over here independently, that's going to cause a lot more necessary evolutions, which is less parsimonious and therefore potentially less accurate. So when we're looking at polyphyletic, monophyletic, paraphyletic, whatever the case, the phylogeny itself can be very useful in helping determine when certain traits arose evolutionarily. And ultimately, what's really fascinating is we can create these cladograms, which shows a taxonomic hierarchy, and we can assign increasingly inclusive clades to certain groups of mammals. So you start off with an outgroup over here, the turtles, and this entire class Mammalia over here, which includes all mammals, and we can start excluding and excluding and excluding based on what characteristics we decide to choose to eventually get to something extremely specific. And that is what a cladogram basically amounts to do. So cladograms are cool and all, but ultimately at the end of the day, this is probably the most important concept, is looking at phylogenetic systematics and then being able to separate the different types of groups. So again, monophyletic, we include the common ancestor and all descendants. Paraphyletic, we include the common ancestor but exclude some of the descendants. And finally, polyphyletic, which is include the descendants but exclude the common ancestor. No common ancestor, that should start shouting out polyphyletic. If there's a common ancestor being chosen as well and included, it might be monophyletic or paraphyletic, and then you have to see whether the ancestors are chosen. And if all the ancestors are chosen, it's a monophyletic, aka a clade, and if only some of them are chosen and others are excluded, you're probably looking at a paraphyletic group. So this is probably one of the most key concepts. That's an introduction to it. Now you should basically learn how to be able to read it, and then after that, you're set for the exam and for other evolution courses. So I hope you found that useful, and as always, best of luck studying, and I will see you in the next video. Take care.